Yeah, so welcome back. I was trying to simplify this thing over here. So you are going to have, so this thing here is going to be 0, right? So e to power negative infinity is going to be 0, and then minus this value over here. So you can basically take this thing over there. You will have this, and then you should take it back there. So what you'll have is going to be sigma 1 over one minus, it's not, again, it's not going to be 1. I'm going to use 0. So you're going to have 0 minus e to power negative 1 over 2. Actually, all this thing is going to be 1 over square root of 2 pi. Multiplied by negative e minus 1 over 2 squared. I hope this makes sense. I just tried to simplify it. So this is where my simplification is. Where this is where I end in terms of simplifying. So 1 over so this is where I end in my simplification. I hope this makes sense. Let me see if we have participant. Okay, yeah. Yes. So this is where I end my simplification, but then this thing can be simplified further. I just don't know how they take it a little bit further than this. But then this is where I would end with my simplification for the question I sent you in the book. So you basically have to substitute the values you have to find your expected tail loss. So another risk measure under conditional VaR is going to be your expected tail loss, right? So again, so this one is your, again, this one is your expected tail loss. I will say so there is another risk measure that you need to know, which I actually have told you earlier on, is your expected shortfall, right? So to find your expected shortfall, now this one, there's a problem with the expected tail loss, is that you should find the value of VaR first before you calculate it. So which can be difficult to find, right? So so the best thing you can do is to find your expected tail loss. So for your expected tail loss is that you can find conditions. So you can have your own benchmark L instead of having a benchmark which is VaR, because if your benchmark is going to be VaR, you will have to find that value of VaR before you can find the benchmark. So now for this one, this is going to be the expectation of L minus X, right? Given that X is going to be less than L. This is basically the definition. I don't know if this is what they use in the book. Yes, or actually in your notes, they say that you're going to find the expectation of the maximum between L minus 0. Again, L minus X or 0. So it's basically the same thing, because at the end of the time, when it comes to discrete, so let's say for continuous, it's going to be from negative infinity to L minus X. It's going to be the discrete, it's going to be f of X dx. I mean, like for continuous. And then for discrete, it's going to be the sum of X less than L minus X. X is going to be less than X. And use X over here. So this is your formula for expected short form. We already saw this in the last question. So I think it was Nicole who asked the question. Calculate the expected tail loss for the last question. Let's see. So this is our question, right? So again, so we know that our VaR. Okay, again, let's look at for this discrete. I think that is going to be much easier to understand, right? So we have negative 15, we have 1%. I think we have 10, and then we have 25. If I remember very well. Negative 15, 1, 10, 20. Okay. 4, 20, 60. It's going to be 20 instead of 25. So 0.04, 20%, 60%. Then what? 0.18. So we already saw that our VaR at 5% was going to be 15, right? So now they want you to find expected tail loss. Let's say maybe this is the question, expected tail loss. So to find your expected tail loss at 5%, by definition, this is what you will have. This is what you will find. You will say that it's going to be the expected tail loss is going to be the expectation of X. Again, how do you write that again in terms of continuous? So it's going to be minus X. Yes, so it's going to be minus X actually. X, given that X is going to be less than VaR, right? So this is what they want you to find. So how do you find this answer? So the expectation in this case is going to be from is discrete actually, is discrete. So it's going to be the sum of the expected value. So again, so it's going to be X, it's going to be less than minus VaR, and our minus VaR is going to be negative 15, right? So we're trying to find the expectation of our so remember that our VaR is 15. So negative VaR is going to be minus 15, right? So here's going to go back to the equation, right? So to find your answer, so your expected, so you're going to have negative. So how many answers are? Okay, so you have only one value, which is going to be negative in this case. I mean, like which is going to be less than VaR, which is 15, right? So you again, so you're going to have 15. So you're going to have minus 15. And the probability for this is going to be what? It's going to be 0.04. So you're going to have 15. times 0.04. So this is your expected tail loss for discrete 0.0. So this is the same as 6. No, it's not 6%. It's 0.6%, I think. So this is your expected tail loss for a discrete. So there's a, what does it look like under distribution? Can you mean the expected tail loss? Okay, I will assume you mean the expected tail loss. So let's say maybe you have distribution. You look at again, so you have 15%, you have like 15%, again, negative 15%, you have 1%, 10%, you have 20%, right? I'm gonna zoom in here. So throughout the answer will come at 0, and then when is it 15%, the probability is going to increase to 4%. At 1% is going to increase. Okay. Okay. Now I'm going to write the PMD, right? The probability mass function, right? So this is how you can show the answers. So this one, I was about to draw a discrete, right? So it's going to be this. So this one, I think is at 20%. This one, I think is at 60%. This one, 18%. This one, 4%. So which one is less or equals to 15%? This one over here, right? So you're gonna have 15%. So you're gonna only have 15% times the probability of itself. So if we were looking at maybe here, so you were going to have negative 15% times 0, 0.04, and then the other is going to be 1% times 0.2. So this will be your, again, so remember that it's going to be negative, right? You will have to multiply both sides by negatives. I'm not sure if this answers your question. So I was actually supposed to teach for, okay, there's a question. Is it me who's speaking? I think I'm going to end here, actually. Because I was supposed to teach for an hour. It's now an hour. I'm not sure how long I took now, but it's more than an hour. But then if you guys want, I can show you something on there's something you might have to know about the stochastic interest rate. If you want, I can give you like 10 minutes for stochastic interest rate, unless if you have something to do. Because this is where my lessons actually end. I was supposed to teach for 5 hours, but I think I have now taught for at least 7 hours. So anyway, because each session I taught last time was more than 2 hours. So I will go to stochastic interest rates to show you guys. There's someone who says that I can do it. I forgot the name. They gave me the name. What is the name? I think it's Ruth. So I have to go to my notes. Actually, there is no need for the notes because I'm gonna have a short summary. So under the stochastic interest rate, here you will be studying interest rate as a variable, right? So it is no longer just the value. Now, okay, now you are going to study interest rate as a variable, right? So, and these variables are and these variables are going to be independent from each other, right? So sometimes they can say that okay, interest rate at time t is going to be random. Let's see, it's going to be random, and it's going to be independent. Okay, I guess it comes from the name of random. So it's going to be independent from any other, again, from any other interest rate, meaning that this year's interest rate does not affect next year's interest rate, right? So how do we find so I'm not gonna show you how to find the expectation of your interest rate, but I'm just gonna write it down. If you want to find the expectation of your interest rate, right, of your interest rate t, you can say is J, right? So this is when, let's say maybe interest rate is gonna be 4%, 5%, 6%, or 7%, or okay, let's say maybe they say that the interest rate can either be 4, 5, 6, or 7%. 4% with 2, again, we have 0.2%, 0.2% for this one, 0.3 for this one, and then 0.3 for this one. It's not going to be probability, right? So if they ask you to find the expectation of this interest rate, so you already know how to find your answer. So I don't think they're going to ask you, but then I think it's important that if you already understand what do they mean by the expectation of interest rate, so this is how they find their answer actually. So it's going to be 4% times 2. It's going to be 4% times 0.2, 5% times 0.2, and then you do the same for the others as well. So this is what they mean by J. So that value is going to be J, is your expectation of your interest rate at time t, right? The same thing can be said about variance. They denote it by S squared. So this is how you find your interest rate for, again, your variance of the interest rate. You apply the same method, you're going to find your values over there. So it's going to be the expectation of x minus x bar squared, right? So so this is what they mean. Actually, these are your i's. I always forget. It's going to be it. You will have j, because j is your mean. So this is what they mean by finding the variance of return, right? So the same thing can be said about the accumulated value, right? If you have the accumulated value for time for n periods, so this means that, again, let's say maybe you are looking at the accumulated value of 1 rand, right? You have 1 rand, so it's gonna accumulate up until period end, right? So you're gonna have 1 plus interest rate for first year, right? So this is for the first year. Next year's interest is not gonna be the same as this year, or at least is independent. So it's gonna be 2% for next year. Again, it's gonna keep on accumulating up until, again, even for the third year, you're gonna have by 3. Up until you reach your end period, it's gonna be 1 by n, right? So there is no need to put these things over here. So this is how you write it, or you can write it simply like this: up to n, t is gonna be equals to 1 plus I t. So this is how you can write your answer as your I'm like, this is how you find the accumulated value of 1 rand, given that interest rate is going to be stochastic, right? So because it's going to be stochastic, they will ask you to find the distribution. I mean, like they can not necessarily the distribution. They can ask you to find the expectation of this. They can find you to find the expectation of this. So they can ask you to find the expectation. So how do you find the expectation of this? Open bracket. So I can write down that thing again. You will have 1 plus I 1, 1 plus I 2, all the way to 1 plus I n. So your answer, you will have the expectation of 1 plus I 1, expectation of 1 plus I 2. The same thing applies up until you get to the expectation of 1 plus I n. So we already saying that I am gonna zoom into here now. To find the expectation of 1 plus I 1, your answer is gonna be the expectation of 1. So this one come from the, so it comes from the definition or the properties of expectation. So you're gonna have I1, right? So the answer is gonna be 1 plus J, right? So you can see that all these things, they will all come to a point where you're gonna have 1 plus J, 1 plus J for each up until 1 plus J. And the answer is gonna be 1 plus I, again, 1 plus J to power n. So this is if they ask you to find the expectation of the accumulated value, right? So they can even ask you to find the variance, right? So if they do ask you to find the variance of this accumulated value, you should remember one thing, right? One thing you should remember is that this is the same as the expectation of an squared minus the expression of an, right? All squared. So you can find this thing separately. So you can say the expectation of an squared is going to be equals to what? So you already know that you will say that the expectation of how do you find the function for an is going to be the sum, like the product of from time 1 up until time n, 1 plus I, right? So again, 1 plus it, right? So squared, because you have squared this thing over here, it's squared. So you will have the expectation of the product t is going to be equals to 1. You will have, so square these things, you will have 1 plus 2 it plus I t squared. You find your answers, so you will say that okay, so you're gonna do the same thing as you did up there, as you did for this one. You're gonna expand your product thing, and then again you're gonna include your expectation individually for each one of them. So you're gonna have something like this. You're gonna have you are going to have at the end, your answer is going to be like this. It's going to be 1 plus 2j. Okay, I think I should just write it up because sometimes some of you can get lost here. So I will say it's going to be the expectation of 1 plus 2 I1. Now we start to do them one by one. This is for year 1. For year 2, 1 plus 2, I2 plus I2 squared, all the way to the time n. You're gonna have 1 plus 2n plus in squared, right? So you apply the expectation like everywhere. Expectation, right? And if they are going to instead to is gonna change. So we're just gonna write J. We already have plus two things. And you have 1, 2, extension of I squared for all. again, when you see something wrong, then you should, again, like I wanted to show you that I wanted to show you I wanted to well, a lot of things like when interest rate has distribution, like let's be interest rates have distributions, and the distribution then to tell you is really low. You can guarantee right? So if you have, so they can say that I has a log distribution, has a log normal distribution with mu and sigma squared. So my advice is that every time they tell you that 1 plus I has a log normal distribution, even if they tell you that 1 plus I, even if they tell you that the expectation of 1 plus I is going to be 1,06, do not put this 1,06 over here, right? Again, this one, again, so this 1,06 or 1, something, even if they tell you that I is going to be, let's just say 5%, don't put the 5% over there, or don't say that 1 plus 5%, and then you put it over there. You should not put it over there because your calculations will be wrong. So you should always find your mu, even if they tell you that 1 plus I has a mu of 1,06 or 1, something. Always find your mu separately. Always find these values of mu and sigma. Don't substitute them there. You can only substitute them if they literally tell you that mu is going to be maybe 0,003. If they tell you that our mu is this, then you can basically just substitute it there. But then if they don't tell you, always find your mu and sigma, right? So anyway, back to the distribution. If this thing has a log normal distribution, the sum, actually the product of 1 plus I distribution. I have a normal distribution with n mu and sigma squared, right? And the lean, the logarithm is going to be of 1 plus it is going to be normal distributed with n mu. If you have these answers, then you can find your solutions, right? So how do you find mu? So finding mu, right? So finding mu and sigma squared from your expectation 1 plus it, right? So whatever value you find, you are going to say is going to be equals to e to power mu to power mu plus sigma squared over 2, right? And then your variance of 1 plus it, which by the way same I t e sigma squared minus 1. This can be rewritten like this. Can be mu over 2 plus sigma. So actually, it's going to be not mu over 2. It's going to again. It's not going to be mu plus this thing. You can already see that this thing is the same as this one. You can just put this value here. You solve for sigma squared 1 plus j 1 plus j 2 squared. Yeah. For your master. I would like to tell you more on this, but we're running out of time. I think I can look at it, which I taught. For example, they had the mean of I is going to be 0.006, and then I went ahead and found this thing. So you can take a screenshot because it's going to cut soon. So anyway, I hope there is no questions at the moment, because we ran out of time. It's been 24 minutes since